So, students, let's get back to where we stopped. We stopped at the last at squares and square roots. Let's 7056. Okay, square root of 7056, and we'll do it by prime factorization and long division. Okay, 7056. Okay, so first I will do the long division method. So 7056. So as per the grouping technique, I told you we'll have to make pairs. Wait, I'll just I'll have to rewrite it like this: 7056, and we have to group these two because our hypothetical decimal point is here, right? So outwards from the decimal point, we have to group. Now let's apply the the long division procedure. So the nearest square to 70 is what? 8 into 8 is 64, isn't it? So 8 into 8 is 64. And 70 minus 64 gives me what? 6. And here you add it. You add another 8. And you get 8 plus 8 is 16. And now you bring down, in normal division, you bring down one digit. But here you have to bring down the pair, which is 56 in this case. So 656 I have. So 164 into 4. Let's check. 4 4 are 16. 6 4 24. 1 5. 4 ones are 4. 5 6. Yes. So 164 into 4. And why did I chance upon 4? Because I told you that when a number ends in 4 or 6, the ending digit is 4 or 6, the square of that number will end in 6. Example, 4 square is 16. 6 square is 36. 4 square is 196, isn't it? Like that. 16 square is 256. So I know that if the number is ending in 6, the square root would have been, the last digit of the square root would have been 4 or 6. And now it is 164 into 4 is what we got, isn't it? 656. So it will be 0. So square root of 7056 will be 84. We'll not proceed further. We don't get decimals because the process stops, isn't it? You're getting 0 remainder. Now, if I want to do it by prime factorization, I just have to be a little good with my tables and division and multiplication. Let me just apply that. Okay. So 2 35s are and 2 28s are. Okay. Then 2 17s are 34. 1 will remain 12. 2 6 are 12 and then 4. 2 8s are 16, isn't it? 16 minus 1, then 1 will remain 16. Again, 2 8s are 16. 2 2s are 4. 2 4 41s are. Okay, and then I can proceed further. But I also know, see, if I can go further, but I know that 7056 is equal to 2 into 2 into 2, okay, into 441. I can stop at this. But 441 itself is a perfect square. What I can do, okay, it will not go by 2, it will go by 3. Okay, so 3 14s are 42, 21 remains, right? 3 7s are 21. Again 3 4s are 12, 3 4s are 12, 27 remains, 3 9s are 7 7s are 7 1s are. You can stop at this itself because if you know it's a perfect square, you can decompose it. Otherwise, you can go up till the last stage. Okay. So I'm rewriting 7056 as equal to what? See, how many 2s are there? 2 1 2 3 4, isn't it? 1 2 3 4. And how many 3s? 2 3s. And how many 7s? 2 7s. So square root of 7056 will be that expression on the right hand side under the square root. Okay, 1 2, one more 2. Let me just forget that. Yes, one more 2 is there. See, 1 2 3. Don't forget that. Correct pair should be there. 3 into 3 into 7 into 7. And now what do? You club them, these two. Then you club these two. Then you club these two. And you club these two. So this, when you're taking it out of the square root, 7056. When you take it out of the radix, it will be 1 2. Then one more 2 from here. Then just 1 3 from here. And then just 1 7 from here. 2 to the power 4. 4 3s are 12. 12 7s are 84. Just scroll up and see what did we get earlier. It's at 84, right? So square root of 7056. Even by the prime factorization method is 84. So, okay. Now let's go to the next number, which is 1225. 1225, right? So there are different ways of doing it. So let us go with the first long division method, which is the nearest perfect square for 212. 3 3s are 9, isn't it? 4 4 16 is beyond 12. So let's go with 3. We have actually grouped it, as I told you. 3 3s are 9. And then you add 3. 3 plus 3, 6. 12 minus 9 is what? 3. You have to bring down the pair, which is 25. So now it's ending in 5. So one possibility is putting a 5. Well, let's check. 65 into 5. What is 65 into 5? 5 5s are 5, 25. 6 5s are 30, 31, 32. So it is 3, 2, 5. When I perform subtraction, I get 0. So you don't have to go further. So that is 35 square is 1225. If you relate back to your Vedic method, which I described, if a number ends in 5, you will write 25 for finding its square. And the 10th place, we have 3. 3 into 4 is what? 12, no? So that is how you get it. That is another way to tell. But otherwise, if you're going with prime factorization, 1, 2, 2, 5, let's check. Let's check this. 1, 2, 2, 5. So here it is. Let's go with 5 itself. Okay, 5. 5 2s are 10, isn't it? 2 will remain. So 22 it becomes. 5 4s are 20. Again, 5 will remain. 2 will remain. 25. 5 5s are 25. Then again, you can go with 5. You can go with 5 itself. 5 4s are 20. 4 will remain. 5 9s are 45. Then 7 7s are 7 1s are. So when I write 1 2 2 5, this is quite simple actually. But looking at practice. And then when you take it under the root, you will also put root here. So root of 1 to 2 5. Take one among the pairs. One among the pairs here. 5 into 7, which is 7 5. So one from each pair you have to take. 7 5 are 35. Okay. Next is 1 5 2 1. 1 5 2 1. Let's go to 1 5 2 1. Pretty much the same technique here. Everything. So you have to apply this technique here. The point is here. 3 3s are 9. 4 4 are 16. So I'll go with 3 3s are 9. 15 minus 9 is 6. 3 plus 3 is 6. Bring down the pair, 21. So let's see the nearest. Yeah, let's check. Yeah. So let's check the nearest perfect square to 621. So it will be 3 3s are 9, isn't it? I brought 21. 60. Let's say 69 into 9. 9 nines are 1, 8, 6 9, 8, 6 are 54. 54 plus 8 is 62, isn't it? So it is 62. So 69 into 9. 69 into 9 will be 621. So subtraction. I can stop at this. So it is root of 1521 is 39. Okay. Let me check the long division method. So 1521, not division, sorry, prime factorization method. These are multiples of 3. So 3 5s are 15. 0, 3 7s are 21. Okay. Then again it will go by 3. 3 1s are 3. Or you can see 16 3s are 48. No, 52 remains remaining. 27. 3 9s are. Then you should know your tables. Otherwise you'll get stuck here because 13 is a prime number. No, 13 13s are 169. 13 1s are 13. That's why I always told you, learn the squares of the first 25 numbers. Okay, write them down, learn them. You should know the squares of the first 25 numbers, the cubes of the first 12 numbers. And for this grade level 8. Now, yes, we'll write that down. So what will it be? 1529. 1529 is 3 into 3 into 13 into 13. And if you're taking the root, it will be under the root. So 1 among the root, it is 3. And among this, it will be 13. 13 3s are 39. So you get it. So there are different methods. I have taught you for decimal also, but I'll not be asking for decimal this time. I'll just be testing knowledge of these kind of roots. If you have a decimal, what happens? Decimal number, you'll have to put a decimal and accordingly go on. Or if it's not a perfect square, you'll not get 0 remainder at all. So you have to borrow. But remember, when you're bringing 0 in normal division, you bring 1 0 down, right? You'll have to bring 2 zeros down in the case of squares and square roots. Okay. So we'll see some examples later on. So from this exam point of view, we'll stick to the syllabus and we'll go only with this. Now let's move on to the next one, which is find the value of x for which 4 by 9 to the power of x. I think I can do it here itself. See, 4 by 9 to the power of x. Look at it. 4 by 9 to the power of x into 3 by 2 to the power of minus 1 is equal to 8 upon 27. We very well know that 4 by 9 can be written as 2 by 3 the whole square, isn't it? 4 by 9 is 2 by 3 the whole square. And 3 by 2 to the power of minus. So a by b to the power of minus 1 is b by a to the power of plus 1, right? So this will be 2 by 3 to the power of 2 to the power of x, okay, into I'll just erase this. 3 by 2 to the power of minus 1. What will that be? 3 by 2 to the power of minus 1. It will be 2 by 3 to the power of plus 1. 2 by 3 to the power of plus 1. That is 8 is 2 cube. 27 is 3 cube. Isn't it? I will just write it down here. Wait. See, I'll just take it here because of space. Okay. So what do I have here? I wrote 4 by 9 as 2 by 3 to the power of 2. Isn't it? 2 by 3 to the power of 2, and that is actually raised to the power of x. Isn't it? 4 by 9 to the power of x. I wrote 4 as 2 square, 9 as 3 square. Into 3 by 2 to the power of 9, I swapped the numerator denominator and I've made the power as 1. Into 2 by 3 to the power of 1. What is that equal to? It is equal to 8 by 27 is equal to 2 by 3 to the power of 3. That will be 2 by 3. You multiply 8 to the power of m to the power of n is 8 to the power of mn, right? 2 by 3 to the power of 2x into 2 by 3 to the power of 1 is equal to 2 by 3 to the power of 3. You should know the perfect squares, that is, I think I'd given you a table if you can recall. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 cube is equal to 8, 2 to the power of 2 is 4, 2 to the power of 4 is 16. Like that you should know for 3 also. 3 to the power 0 is 1, 3 to the power 1 is 3, 3 square is 9, and so on. 3 cube will be 27. So if you have knowledge of this basic, you don't have to go up to 3 power 10 and all, 3 power 3, 3 power 4. If you're able to have, I mean, if you know this, you can easily solve the problems on exponents. Now, what is it? Base is the same, no? 2 by 3. What is a to the power of m into a to the power of n? It is a to the power of m plus n, right? So, you have that m and this is n. So, you can say 2 by 3 to the power of 2x into 2 by 3 to the power of 1. So, 2x plus 1. I will add the powers is equal to 2 by 3 to the power of 3. You should know the laws of indices. We have done a lot of sums on this. Just recap, then you'll be able to understand each step. Now the bases are same. If a to the power of m is equal to a to the power of n, you can infer that m is equal to n. If m is not equal to n, then that means a should be equal to 1, I told you. But now we are not going to do that because the base is the same. So equate the powers. 2x plus 1 is 3. 2x is equal to 2 or x is equal to 1. So you can get a sum, similar type of sum where we are testing your knowledge of this. Okay, now look at this. Study the bar graph and answer the questions that follow. Okay, first one. In which sections the number of girls is greater than the number of boys? So this is a bar graph, double bar graph. And the x-axis is mentioned. This will be your y-axis. I told you the independent variable always comes on the x-axis. This is the origin. We denote it by O. This is like, technically it's like a number line, two number lines placed at 90 degrees. And here on the y-axis, that is called the dependent axis, we have the number of students. Otherwise, I told you it represents the frequency. So it's representing the number of girls and the number of boys in different sections of grade 7. There are different sections. So if you look here, the gray area refers to the girls and black one is boys. So which area, in which sections the number of girls is greater than the number of boys? Look here, where is gray more than black here? Not here. It is here, isn't it? See, 7A, you can see the gray is bigger. The gray is showing a greater number than the black one, right? So it's only in two cases, that is 7A and 7D. In 7A and question number A, it will be 7A and 7D. If you see, the gray is more than the number of the gray portion is more than the black portion. So number of girls is more in these two sections. So it is pretty simple actually, it will be. Okay, here we have not asked you to draw a graph. I have not asked you to draw a graph. I have just asked you to analyze a graph. If you have asked you to draw a graph, so it's fine. But mostly you will be given questions where later on, when you come across situations, you'll be given a graph, and from the graph you have to infer many things. Okay, the graph is already plotted for you. You have to understand, you have to analyze the different components of the graph and analyze what is it. So this is one analysis that we could derive. That is number of girls is more than the number of boys. In which sections the number of boys is maximum? So now I have to just look at the number of boys. There is no comparison like here because I'm only talking of boys, and in which section it's maximum number of boys. So look for the black, where in which section the black portion is showing a greater number. So here in 7A, it is 15. 7B, it is 30. It's the tallest one, right? I can see the tallest bar here. 7C, it is 20. 7D, it is 20. So it's equal. 7D, it is 25. So here it is 30, isn't it? So it will be, the answer will be to the B part will be grade 7B. It will be 7B. Next is moving on. So this is how it will be. You might be asked similar questions or something related to this. So be prepared. Next. A fort had rations for 150 soldiers for 30 days. After 12 days, 30 more soldiers joined the fort. How long will the remaining rations last? So the fort had, what is the scenario? So there were 150 soldiers for 30 days. Okay. Now we just analyze. If there are more soldiers, the food will last for less days. More people are eating, more soldiers are eating, isn't it? It's like, it's inverse. More soldiers, the rations will last for less days. If there are less soldiers, the people who are consuming is less, isn't it? Less food is consumed. So here again, we are assuming that all of them are eating uniformly, like packets of food, we could say. So something like that, associate something like that. So that means it's a case of inverse variation. But let's see. Now we just can't put the data just like that. We have to, there's small analysis and some calculation. So always I told you, make two columns like this. And you can say X is the number of soldiers and Y represents the number of days the food will last. So in the first case, it has rations, it has 150 soldiers are there for how many days? For 30 days. Okay. So that is one story. Then after 12 days, now after 12 days, that 150 soldiers have eaten some amount of food. The number of soldiers will become what? 150. And the food availability, 30 minus 12 is, now whatever food is left over, it will come for how many? 30 minus 12, which is 18 days. The same 150 soldiers, if only 150 soldiers were there, after 12 days, 30 minus 12 is 18. So the food would have been enough for next 18 days. Because 12 days, as per calculation, it will be available for 30 days. 12 days is already over. So 30 minus 12 is 18. But that is not the scenario, because after this, what happens? 30 more soldiers join. So 150 plus 30. Now the strength is 180. Now we have 180 soldiers. Okay, 180 soldiers. And now we want to know how long the food will last. Naturally, it will last for lesser than 18 days. When there are 150 soldiers, the food will last for 18 days. With 180 soldiers, the food will actually last for lesser days, and we will calculate. So this is the case of, you can say this is, we have to analyze between these two cases, because we are studying the scenario after 12 days. No, this is X1, this is X2, this is Y1, and this is Y2, which is the unknown. I put a question mark. So in the case of inverse variation, X1 into Y1 is equal to X2 into Y2. So 150 into 18 is equal to 180 into Y2. We'll keep it as Y2 because it's the unknown. So again, you have to cross multiply. You bring that 180 down. 150 into 18 upon 180 is equal to Y2. 0 and 0 will nullify. 18 ones are, 18 ones are. I'm getting 15 days. So simple. The food which had to last for 18 days will only last for 15 days with the addition of 30 more soldiers. So from 150, it is becoming 180. And that happens when? After 12 days. So we have to analyze this portion, these two places, because this is the scenario after 12 days. The beginning, everything was this was good. But when we're comparing, we have to see on the same level. After 12 days, what happens? Okay. For these kind of sums, you have to analyze in this manner. Next is the time needed to paint a fence varies directly. So if you look here, the question itself is giving you the hint there. It is direct proportion. It varies directly with the length of the fence. Okay. Now, Sinchan wants to paint a fence. If it takes 2 hours for him to paint 300 feet of fence, how long will it take to paint 500 feet of fence? So here, even if they didn't mention the word varies directly, I would have understood it is direct proportion, because if the fence is small, it will take some time. If the fence is larger, longer, I mean, whatever, the length is more, a longer fence, I would say, the time would be naturally more, isn't it? So longer the fence, longer is the time taken, more is the time taken, I could say. So that is simple logic there. So it is direct variation. So the main thing in this problem is we have to look at the scenario from a practical mindset and understand first of it. It's like I would say, it's not intuition, it is common sense. Okay. Is it direct or is it inverse? If you understand that, it's like half the battle won. Then you can just apply a simple calculation. If it's inverse, as we have seen in the previous case, it is x1 into y1 is x2 into y2. But in this case, it will be different. We'll see. So what do? Now I'll put the data here. So I will take time as, let's say, x, and I can take a fence length as I can take it as y. This will be in hours and this will be in, of course, meters here. Sorry, feet. They're given feet, right? Length of the fence is, you can use anything. It could be meters or feet, but in this case, they're given meters. Feet will go with feet. Okay. So now let's put the table. So time is what? 5 hours for 300 feet of fence, isn't it? 300. So this is my x1. This is y1. Then next, what is happening? For 500 feet, how long time it will take? Time, I don't know. That is x2, which is the unknown here, question mark I'm putting. Y2 is 500 feet. So in direct proportion, isn't it? It's direct variation. So it will be x1 divided by y1 is equal to x2 divided by y2. See, some of you once told me there's some arrow method and all that is mentioned in some books. You can go ahead with it. Depends. If you have gone through that method, that is also fine. It's how you understand or how you interpret it. So if it's direct variation, if you're going with the arrow method also, you can apply the arrow method technique also. If you have learned it that way, that's fine. But this is how I am teaching. And if you're understanding with the method I am going, I'm applying this logic. And I'm saying that 5 by 300 is equal to x2 upon 500. That is x2 time I need to know. So how long will it take? So it will be 5 by 300 into 500 is x2, 0, 0, 0, 0. So x2 will be 25 by 3 days, hours. Okay. 25, 3 8s are 24, 8 1/3 hours. Means 8 hours, 1/3 hour means 20 minutes. Isn't it? So, see, for 300 feet of fence, it takes 5 hours. It's longer, no? 500 feet. So, if it is 500 feet, it will naturally take more time. And in this case, it will take 8 hours and 1/3 hours. 1/3 hours, you can write 8 hours and 20 minutes. 1/3 of 60 minutes is 20, isn't it? 1 by 3. So, this is it. Next is, okay. This is a sum on. We have a few more. Okay, we will just do this and then I'll take over in the next session. So Anne scores 10% less than Betty and Clara scores 20% more than Betty. Okay, our reference point is Betty in this case. Okay, so Betty is scoring, I don't know what Betty scores. I'll call it as Betty is scoring M marks. Okay, M. So what will be Anne's score? Anne's score will be 10% less than Betty. So M minus 10% of M is Betty's score, Anne's score. Anne's scores, see, we are referring, we are saying that than Betty and Clara also than Betty. So Betty is a reference. So Betty's marks are M. Okay. So Anna will score Betty's whatever, how much? 10% less than Betty. So whatever Betty is scoring M minus 10% of M. And Clara will score how much? She's scoring 20% more than Betty. So Clara will be scoring M plus 20% of Betty, which is 20%. Okay. So this you need to understand. So Clara scores, and Clara's score is given. Okay. That is M plus 20% of M is 960, which is Clara's score. It's given, isn't it? So Clara's score, if Clara's score, see 960, this is Clara's score. So equate that M plus 20% of M to 960. So M plus 20% means 20 by 100 into M is 960. And what is that? 21s are 25s are M by 1 plus M by 5 is equal to 960. So when you cross multiply, you will get 5M plus 1M. I am taking LCM here. Okay. 5M plus 1M upon 5 is equal to 960. 6N upon 5 is equal to 960. Or you take the 5 up, M is equal to what? See, 960 into 5 and the 6 will come down. 6 ones are 16, 116 are 96, so 160 into 5, which is 800. This is, M is what? Betty's marks, isn't it? Betty is getting 800. Clara's we already know, which is 20% more than Betty, that is 960. It's already given. From there only we were able to analyze. And what is Anna's score? Anna is 800 minus 10% of 800. 10% of 800 is 80. 800 minus 80 is 720. So this is Anna's score, and we have Betty's score, and we have also, anyway, already given, and Clara's score is anyway given there. So we have got all the 3 students' scores. So this is how you will have to apply percentage. Okay. So in the interest of time, I'll just stop here because I'll have to, I cannot lengthen the video any further. I will stop here, and there are a few more questions left, and I will just get back to you in the next session. I hope up till here, the questions have been, the solutions have been clear to you.